So our second speaker of the day is Louis. I think 13, 14 years of experience working as a full stack JavaScript developer, now currently working as the chief engineer at Wealth Wizards. Yeah, Louis, over to you.
Yeah, so well, first of all, just thank you very much for inviting me to speak. It's always a privilege to speak about great technology like this, and always difficult to follow such a great talk from Sven. So thanks, Sven, for that as well. I'm going to talk a little bit about my experience at Wealth Wizards, the journey we've been on in moving to serverless from a kind of microservices stack in Kubernetes, and how we've used the serverless framework. But particularly I'm going to focus in on Step Functions as one of the offerings from AWS and how we've used that for our system. So a little bit about me. I'm from probably the greatest city known to man, which is Birmingham. I grew up down the road from Cadbury's Chocolate Factory. I went to university to study my passion, which was history. I did that for 3 years, and then I figured out, how am I going to get a job? So I did a conversion master's course in computer science at Birmingham Uni, and it's just, I guess, a reminder that you can start late and you can get into computer science, and I've been doing that ever since. So for the first sort of 6 or 7 years of my career, I worked mainly on Java, working for a number of companies. Probably the highlight would have been at the BBC, with a sort of sprinkling of jQuery and such frameworks as they started to arrive. And then I kind of made the switch maybe about 7 or 8 years ago to working sort of fully on JavaScript, working on a number of kind of mobile frameworks, and with building web services in Node and Express, and for the last 5 years been working with React. And I turned up at Wealth Wizards about 4 years ago, 4.5 years ago, and what we had at the time was a legacy Angular and PHP stack, and I was tasked with trying to move it to something more modern. And so at the time we went with Kubernetes, and we started writing a number of microservices to achieve what we wanted to do. And at Wealth Wizards, what we're all about is trying to automate financial advice. So we were typically building applications to run calculations and work out what the best way customers could invest their money, how to invest their money to get the best return in retirement. And so we built a whole ecosystem around this. So we had things like we built a set of Jenkins sort of CI/CD type pipelines to be able to deploy our stuff out to Kubernetes. We built a kind of Slack integration sort of commands so that we could just deploy services out to different environments for different tenants, and all the sort of typical tech that's involved with that, Terraform and so on. So it was a big sort of under a big task. We used Vault for security and so on, and it was really really good to be involved in, and we achieved a lot, I suppose, and moved things forward. But what we realized really quickly was that we had to create lots of different namespaces to keep our applications separate for different tenants, different databases running in that were completely segregated for sort of security and sort of privacy reasons. And we started spending a lot of money running big EC2 instances, it was not a cheap affair whatsoever. So I suppose we learned really quickly with Kubernetes that it was a big burden on our platform team. Even during the night, you're paying, as Sven highlighted, you're paying by the hour. And also, when I wanted to create myself, let's say a queue, or perhaps use a different database, it often involved more work in setting these things up. And so as a result, I suppose as an engineer, I felt, despite having a really good platform team, that I felt that I was always kind of queuing for the next thing that I wanted to do. It wasn't something that was at my disposal to just get going real quick. So this is when we started to look at the serverless framework for serverless applications, and it's a YAML-based kind of the way you express your sort of templates and so on. And it's obviously fair to say that as a framework, it also supports GCP and others. So it's not tied to AWS, but we were already working heavily in AWS, and so we went down that line for our serverless kind of use cases. And this is when we started to look at a number of different things like SQ. We started using SQS and we started using Dynamo and so on. But we soon got to thinking about the fact that a lot of the things that we would do were kind of workflowy. They were kind of do one thing, then another, spawn off and do other parallel things. And then that's when we looked at step functions as a technology that AWS kind of offer. And I think it's fair to say that every business I've been in, more or less, has had workflow type systems in their sort of product suite, that they've needed to do. And so this was kind of something that was really interesting to us. And so we did some investigation work into step functions. And so I was kind of promised out of the box that I would be able to, I wouldn't have to write so much kind of code, retrying logic. I wouldn't have to worry too much about parallel execution and that sort of thing. This was all taken care for me. And so I suppose that what I'm going to reveal to you in this talk, I guess, is that a lot of the things that I was promised are actually true, that I was able to utilize AWS for these sorts of things. And so what was the kind of workflow that we had? So typically we build applications for end users, members of the public, or advisors, financial advisors on the phone to customers. And they typically we get a load of facts from the customer, or we can suck in data from elsewhere. And these are financial facts about people, how much they earn, what their income is, what their how many properties they might have, what kind of investments they might have. And so on and so forth, whether they have a spouse, whether they're in good health, these sorts of things, all the kind of facts that influence financial advice. And so we capture all those things and we store them via our API, and we store them in a kind of Mongo database during our kind of Kubernetes sort of framework sort of way of doing things. And then we run them through an algorithm to generate some advice. And then typically the thing that the takeaway thing for a customer in financial advice, the thing that they pay for is a regulated document that states what they should do with their money. It's then up to them whether or not they go ahead and transact and do what we recommend them to do. But the really important thing that we generate for them is a document. And this might be a Word doc, it might be a PDF that we need to create. And we often then upload these things to third-party systems and so on and so forth, depending on the customer. So that's the kind of workflow, and the sort of the kind of phase one of this, with the version one, the V1, what we did in Kubernetes is we had this kind of orchestrator service, which was the thing that we hit to trigger the whole flow off. And this was when we built it in the first case, it was just a Node.js service. And we managed and built all the kind of retry logic inside it. And we went off and we hit another service, the kind of advice logic service, to go and calculate the advice for the customer. And this would involve calling other sort of generic calculator services that we had, which were kind of like lambda functions, but written as express microservices running in Kubernetes. So this would go off and generate a big JSON payload, sort of representing the advice that we needed to give for our customers. And then we would typically go through a flow where we would maybe use React on the server side to convert this to an HTML string, and then we would convert it to a PDF of another service. And we'd store it in MongoDB. And so that was our kind of framework in V1. And it worked okay. But I think we soon realized that, we needed to put some kind of queuing in there because it wasn't really very scalable. This whole orchestrator was holding a lot of stuff in memory. It was doing a lot of retrying and a lot of own custom type logic that we were maintaining ourselves, and stuff that we could get for free, if we used other tech. We were also having to support a Mongo database running in one of our clusters, and none of us are really particularly kind of experts with tuning and sort of maintaining and scaling Mongo. So that was something that we were taking on as a responsibility. So that's when we kind of looked at step functions. And what we realized really quickly, if you're not familiar with them, they really are just a series of JavaScript functions that can be glued together. They don't have to be ones that you write. They could be out of the box ones that they offer. But they also could be things like you can say, I want to go and send something to a queue, and you can express that in the config, or you can write to a database and so on. But essentially, they're just, in the case that we use them in, where we just gave us the ability to say, run this Lambda function, then run another one, then another one, and each function could do different things. When you kick a step function off, it's fire and forget. It doesn't sort of wait around to give you a response. It's not synchronous in that way to tell you whether or not it's succeeded or not. It just says, right, I've started it off. It's now kind of pending. And again, ideal for workflows, and it gives you a lot of things out of the box. So just going to illustrate real quick just how you can you start to describe your step function. So you can use the serverless kind of framework, which is in YAML, as I talked before. And when you describe a step function, you have to describe what's called a state machine. A state machine is really just a series of states, and a state is in our case typically maps to a Lambda function. So in this case, I'm saying the first thing it's going to do is it's going to start at the generate solution state, which is a task. And that involves using the generate solution Lambda function. So it will start at that Lambda function, and then it will move on to the next step and the next step and the next step. Now there's a plugin for VS Code where you can visualize this YAML and you can see what it actually means. Or when you actually deploy it to AWS, you can start to see how it actually looks. So what's really nice is we could model the workflow that's so crucial to our business. We can model it in YAML, and this is then drawn for us in a nice diagram. And what you can see here is that I'm executing a Lambda function. I'm then deciding what to then go and do. Is this just about this point, go and generate some advice, don't generate any documents and finish? Or is it about, now I need to go and build some PDFs and some docx kind of documents and for the customer? And this kind of repeated block here is illustrating the fact that it's generated more than one, and it's done those in parallel because of the config that I've specified. So as I said, they're just Lambda functions. They can map to Lambda functions, or they can map to other AWS services. Here we're just saying that the generate solution, this is the handler, this is the memory I've given it, and so on. And here are some environment variables. That's all it is, nothing particularly complicated. And it doesn't have to be just Lambda functions, as I said. So you can use inbuilt kind of decision logic that you get for free in Amazon. So here what I'm saying is that I'm going to reference a variable from a previous Lambda function in the flow. And then based on that, I'm going to decide which path to go down. So again, you don't have to write custom logic for that. You can just use the built-in kind of decision logic that you get for free with step functions. What was really useful for us, though, is the kind of ability to generate documents in parallel and to do these dynamically. So for us, based on the tenant and the type of financial advice that we are generating, so like retirement, investment, that kind of thing, we need to decide at runtime how many documents and what the type of documents that we need to generate. So typically we have this flow where we create some HTML and then we convert it to PDF, and that's the end. Or we decide, oh, we need to just generate a docx. So what we were able to do is we were able to export an array during the execution, and based on the tenant and the type of device, we could export an array which contained the number of objects, and those objects represented the type of document that needed to be created and the format. And then this little iterator here allows you to spawn off a flow containing generate HTML, then PDF, or generate docx, and that runs in parallel. So this thing here allowed us to specify how many can run concurrently. And the nice thing here is that unlike our V1 of the service, this is not running in memory in the same process of the Node.js application. This is actually potentially running on different sort of in processes and so on, different boxes. So this was kind of a really useful thing for us to be able to run things in parallel and do it and create it dynamically at runtime. so we could scale our application a lot better. So once you've kind of triggered the thing to start, you can see the execution that's running. This one's succeeded here, and then when you click into it, as I've shown already, you can see that the fact that the path that it's gone down and whether or not it's succeeded or not. So that's really useful, visualizing the workflow, and it's very useful as well when things when you're trying to debug stuff perhaps and see why stuff has happened. So in this case, I can see some of the variables that were passed between the different states. And when something goes wrong as well, you can see here, there's this, the dreaded null pointer exception here. So I was able to sort of, look down into the code and work out what on earth's going on. So that's a little brief overview of that. What's kind of some of the challenges that we had? So we, the classic dreaded thing with serverless applications is the fact that you can you've got cold starts and so on, and when you're introducing potentially sort of step functions, and there are multiple different nodes within the application, then there's this problem of potentially there might be multiple cold starts if you're going off and calling different AWS services. So we use this plugin that was quite nice. It allowed us to basically ping the AWS services during the day between these hours specified here, and we were using this MIDI framework which allowed us to execute early, so that we didn't actually execute any of the business logic inside the serverless Lambda function that we were warming up, but it just warmed it up and exited early, and this kept the costs down. So the serverless plugin, warm-up plugin, was useful for us. Amazon have introduced another way of tackling that as well, which you can look into, but that was good for us. We could wire it in on our particular function by just adding this warm-up enabled true, and that was useful. Other thing which was good, which was that you can plug up in serverless, you can plug up your step function state machine directly to an API. But because it's fire and forget, there isn't really a way of validating the inputs before you start the execution of the step functions. So what we did is we created an API and then instantiated the step functions from within the API. And that enabled us within the API to validate the data that was coming in before beginning a step functions flow and finding that it failed asynchronously halfway down because some data was missing. So that was something that we could put in front of the step functions and API using MIDI to validate the data coming in. So that was another way in which we got around that particular issue. Sometimes you might want to actually delay the execution of the next bit of the step function for a period of time, and you can use this built-in wait type to wait until an amount of time has passed, or you can actually export a timestamp from the previous state in the state machine and then move on to a wait state. Now what that does is it means that, let's say you could do a whole load of stuff. Imagine if you're in the energy industry and you're taking a customer on board, you might want to do a series of things. You might want to create their account. You might want to start to call the industry to go and kick off the process. But then you might want to wait for 2 weeks during a cooling off period. And what's really nice with step functions is that you can then pause the execution of the step functions for up to a year. And then that will allow you to then maybe begin something again once a period of time has elapsed. And that could be quite applicable, I think, if you were using this sort of stuff, within mortgage applications, energy, broadband, these sorts of things could be quite useful as an architectural kind of pattern there. So Sven talked a little bit about Mongo. We've been maintaining our own MongoDB clusters. We use Atlas as well, but ended up with our own MongoDB. We had to maintain that ourselves. Again, using S3, using Dynamo to store our advice and our data was really easy with the AWS SDK. And again, it's a managed service. You're not paying any platform engineers to do anything particularly. And as Sven's kind of highlighted, you can get really high throughput, things like scatter writes and being kind of really clever with your indexes can be really good. But I would say that Dynamo, unlike Mongo, where you can index everything under the sun, it takes a lot of getting used to. You express your table in the serverless framework like so, which is fairly easy. But then it gets quite tricky because, if you're used to SQL where you can do all sorts of group bys and joins and so on, you can't do that sort of thing. So you have to pre-can your data in such a way that's going to make it easy based on your access patterns to the data. So it takes a lot more thought, I would say, from a developer point of view to actually to get the data right, ideal for your application. So you can use the AWS SDK to query it, and as you can use this kind of like syntax to scan and page stuff, as Ben highlighted. But there's this concept of partition keys, and I'm not going to go into loads of detail here about this. There is some great videos that you can watch by AWS on this, and this whole concept of a single table design, and that's something that we've gone with. But one thing that's worth a good practice is to think about your access patterns, to map them out in like a spreadsheet or something before. And this AWS offer kind of like a workbench where you can start to play around with the table and see how it will work. But there's this concept of like overloading partition keys. So partition keys have to be globally unique unless they are they have an accompanying sort key, and therefore in that case the partition key and sort key themselves have to be globally unique. So, but in a single table design, you can quite easily model hierarchical relationships, one-to-many relationships, by overloading the index. So typically we have these concepts in our system of advisors and clients, and we follow this syntax of prefixing the keys with advisor hash or client hash or different things like that. And we can quite easily, the way we store our data, using clever sort of strategies for the partition keys and so on, we can get the data and store it in such a way that it makes it incredibly fast to read out the database. And bear in mind, if you are going to look for a specific record, you do have to specify the primary key in your query. So, the partition key, and this is quite important because this is what AWS uses to position and place your data in the best place for a sort of optimal reading of it. So Dynamo, some great stuff online, you can read that, but we've found that you're not got the overhead of Mongo of having to maintain that yourself, and it's been very performant for us. Just quickly, a final thing on testing, I would say, just finally testing all the step functions and so on. Unit testing, you can do all that stuff. It's still the same, really. It's just JavaScript. You can pull the functions out into a different module and test that in isolation. You can test the AWS SDK if you want, about what parameters you're passing in. But maybe unit testing in this new paradigm has slightly less value. Your kind of integration level testing starts to have more of an importance. So we typically have kind of not used the offline offerings. Typically people try and do this, they try and replicate the workings of S3 and Dynamo, and AWS have provided some Docker images for this, but I've typically found that these things, and others in my team who've used things like AppSync and such technologies, there's always gaps between the way they operate in the real world and the offline versions of them. So it doesn't really truly become very representative of how things really work. So what we've tended to do is actually in our tests to just run the integration tests, pointing at the test environment and just using the SDK to populate S3 or populate Dynamo with unique pre-canned data so it doesn't conflict with other test runs before running our tests, and just run it against the real environment. And that's been pretty quick and very performant for us. And similarly with Lambda functions, just executing them, and because you're really using the real test environment, you can get more representative kind of realistic output of what's really going on, and more confidence as well in your tests. So that's a kind of just a brief whistle-stop tour of step functions and hopefully some small pointers on Dynamo. we have, I think there's a fair to say it is a lot cheaper, and just the whole suite of things, Lambda at Edge for your front end applications, giving you lots of different options with databases and streaming technologies and so on. But the workflows have been really successfully modeled for us using step functions, and I'm sure we'll continue to use those over the next year or two. So I would definitely say, as Sven say, you are locked in, but there's so much to offer you that it's worth embracing it as a platform. So thanks very much for listening. Any questions?
Really enjoyed that again, particularly the delay of execution, something that I'd never, been made aware of or had made myself aware of before, but yeah, quite interesting indeed. We have got quite a few questions. Something I wanted to run past you was, I think you touched on this slightly, but sort of step functions versus SQS, why you would use one or the other. And I think, correct me if I'm wrong, you mentioned maybe using them concurrently.
Yeah. I mean, good question. Often something. And actually, before we use step functions, I wanted to use SQS because I'd actually used it for the previous chunk of work that I'd worked upon. Sometimes you get that feeling of resistance, don't you, when you've got to learn something new. But what I found when I've used SQS for these types of things is that you end up building a lot of the kind of handling of failure and so on, decision logic about what to then go and do yourself. So you might put something on a queue, and then you might have to then think about another queue to put things on when certain states are reached. So I think you end up having to programmatically, at least, mimic some of the things you get for free in the step functions YAML DSL that you can express things in. You obviously don't get the same visualization as well of an end-to-end run of a record. I don't think you get that same visualization of it. Let's just say that. So that would be my one thing. If you're wanting to get these things for free and you're doing multiple steps in a flow, the step functions are really nice. Perhaps worth as well doing just a quick deep dive into the cost for you. I do think you pay per transition, I think, of the states in the step functions. So it might be worth just measuring what's cheaper for your organization as well, as another thing. Of course, as well, because it's all in AWS, there's nothing to stop you in a particular state of your state machine contacting an SQS queue and putting a record on SQS. So you could, for example, in this example that I gave, there it is, this one here. So this error handler, in our case, what we actually did is we just marked a record in Dynamo as being in an error state. But that error handler could be something that writes to an SQS queue, like a dead letter queue.
Yeah. Okay.
So in a sense, you can use them both, and you could do it all in SQS. But I think this kind of the way in which you can run things in parallel and express that all in using the framework is really useful. So.
Okay. And slightly more serverless general, I think Brian was sort of wondering, so he's got a Docker build that on a decent machine takes about 30 minutes to execute. So that's building an Erlang compiler. So is it possible to run a Docker build inside of a Lambda function? He to credit to Brian, he did say this might be slightly off topic, so no worries if you can't answer it.
Yeah, I mean, I'm not sure you can. It would be a kind of bit of a mix of, probably doesn't feel like the right thing. It'd be interesting to see what you can really access from the execution environment the Lambda function. I'm not really sure you could do that. Yeah.
Okay. And Louis, back to you. So you mentioned that there was quite a lot of upskilling, and the team around you basically weren't too aware of how to go about moving towards serverless architecture and service infrastructure. So what were some of the key resources? I guess, how did you help the team around you to go about upskilling and really becoming sort of masters of serverless infrastructure?
Yeah, good question. I think the brilliant resource is a lot of the stuff that is it Yang Kui? Is that how you pronounce it? Sven probably knows of him. So I went to a talk by his at a conference in London maybe 2 years ago, and it was really inspiring. So I think a lot of the articles that he writes tackle a lot of the problems that that you've highlighted. So a lot of reading, a lot of his stuff. On Dynamo, we watched an amazing talk as a team. So collectively as a team, we watched an amazing talk on Dynamo on a single table design, which really helped us on how to structure our data. And similarly, some of the AWS tech talks on things like step functions that were really useful. Coming back to one of the previous questions, and as well in answering this, which is we used Epsagon, which is an alternative to Lumigo, to sort of trace your stuff, and we glean that from some of the articles. When that guy Yang Kui was at Darzen, they created a number of libraries. There's an npm library called Darzen Power Tools, which gives you some really nice instrumented ways of capturing things like correlation IDs in your serverless applications. So it typically wraps around all the typical AWS libraries and allows you to, in a single request, be able to find things. One of the things that we had with our Kubernetes platform is, and I wanted to mention this earlier actually, which was like centralized logging.
Okay.
And when you typically, what I've found so far, there aren't really kind of really nice places to sort of get all the logs from all your AWS resources in one place without doing some clever stuff. And so I found ways of doing that from some of these articles that Yang Kui had done and so on. So yeah, I think it's just trying to find those serverless heroes. I mean, Sven's obviously one of them as well. So, all following these people is really a good way of doing it. And the AWS talks as well online were really helpful.
Okay.